Welcome back to Engineering 5.0. We are starting an exciting series on generative AI covering the what, why, and how of this fascinating technology. One concept we'll use to explain the what of generative AI in this video is Bloom's taxonomy. I haven't seen generative AI explained in these terms. Using this concept was a light bulb moment for me while teaching some of my students. Generative AI refers to algorithms that can create new content, whether it's text, images, music, code, or even engineering design. Unlike traditional AI, which analyzes existing data and basically just categorizes the data into classes, for example, is this a cat or a dog, or cancer or no cancer, generative AI can produce original work, or at least seemingly original work. Even human artists or engineers take inspiration from existing work to come up with original work. And in a sense, generative AI does the same. Generative AI has come a long way from the early days of neural networks. Today's models are incredibly sophisticated thanks to advancements in machine learning and computational power. The first useful neural networks used AI for pattern recognition. They could classify letters, and for example, in optically scanned text in a given language.
One of the earlier networks in the Linnet series were able to achieve above 98% accuracy with a relatively simple 5 to 10 layer neural network architecture and only tens of thousands of parameters. This is an example of generated audio using voice cloning in a generative AI video. Now, moving on to actually recorded audio.
These early applications laid the groundwork for the more advanced generative AI we see today. This 2017 paper, Attention is All You Need, is considered to be a landmark that has made the current era in generative AI possible. The paper proposes an architecture called the transformer. There are tons of great videos on explanations of transformers, which I'll link in the description, and I will also go a little deeper into the architecture in another episode of this series. In this particular paper, they use translation between languages as a test case. The BLEU score mentioned here is a measure of how good a translation is compared to human translation. The same architecture of neural networks has now been applied to a lot of other use cases for generative AI with good results. The famous ChatGPT series of generative AI systems from OpenAI also refers to the same transformers, GPT meaning general purpose transformers. So now let's switch the topic a little bit to Bloom's taxonomy. So Bloom's taxonomy is a framework used in education to classify learning objectives. At the top of the pyramid, the taxonomy is often shown as a triangle or a pyramid. At the top of the pyramid is create, the highest level of cognitive processes. Learners, however, are assumed to start at the lowest levels, such as remembering things that they have seen and understanding, and gradually work their way upwards to apply, analyze, and evaluate. By the time they become experts, they reach the create level, where they can produce new and original work. At the create level, learners are expected to produce new or original work, such as writing an essay, designing an experiment, or developing a new product. In a sense, you are an expert in a given domain. So you can create things that are really original. However, even kids can create things. It may not be that good if you're not an expert. Generative AI mirrors the create level by generating original content. And just like students, they create new work and it may not be perfect. So AI models produce output based on training data, but unique, like extrapolate from the training data. So generative AI learns from vast amount of data, recognizing patterns and structures. And once trained, they can generate new content by predicting what comes next, much like a writer crafts a story. We'll dig deeper into the how in another part of the series. So generative AI can be too creative at times, leading to hallucinations, producing content that doesn't make sense. This means humans need to spend more time curating these creations to ensure quality and accuracy. In the past, imagine hiring an artist to create original artwork for your gallery or for your house. They might only produce a few pieces a day or even months or years. So with generative AI, it makes it much cheaper and faster to produce a whole bunch, hundreds, thousands of different artwork. But the real human input is now on sifting through that and evaluating these creations. So just like Bloom's taxonomy, evaluate comes just before create. However, we want to flip the script a little bit, where evaluating whether a solution is correct or good sometimes requires even more expertise. In fact, in Benjamin Bloom's original work from 1956, The Taxonomy of Educational Objectives, the handbook, he does list evaluation as higher or a step after synthesis. He defines synthesis as the putting together of elements and parts so as to form a whole. This involves the process of working with pieces, parts, elements, and arranging and combining them in a way as to constitute a pattern or structure not clearly there before. So it's the act of creating, or synthesis is just a different word that's used. While evaluation is listed as number 6, judgments without the value of material and methods for given purposes, qualitative and quantitative judgments about the extent to which material and methods satisfy criteria. Use of a standard of appraisal. The criteria may be those determined by the student or those which are given to him or her. So evaluation is actually just part of creating. So when you try to create new things, you try something out, and if you don't like it, you throw it out. But if you can create more things faster, you're likely to look into a lot of different things before you settle into a good quality solution. So in a sense, you are going to be able to increase your quality of output because you've looked into enough data and you just don't settle on just the first, second, or third output that you created. You now have the luxury of creating thousands of different things before you settle on, before you choose the one that you like. For example, if we use generative AI in software engineering, then it will now be easy to create a lot of software that could work in a few cases, but the human will need to go in and make sure that it all connects together well and it works in all different cases. So there'll still be a lot of knowledge and practice ultimately required in evaluating the work that is produced. This can apply to other engineering fields as well. A quick plug, my company Renaissance AI is building tools to help engineers create using generative AI so they can spend more time building more things at a higher quality. Back to the topic, we'll delve a little bit more into the why of generative AI in the next episode. So to recap, generative AI is all about creating new content, much like the create level of Bloom's taxonomy. Stay tuned for our next episode where we'll explore why generative AI is so important. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more insights from Engineering 5.0. Thanks for watching.